Hi, everybody. I'm back. We're doing linear functions still. Looks like lots of slope-intercept. You can't believe how many times in the 30 years I've taught that students come up and look at me after an entire year of algebra, and they look at me and they say, slope, intercept, like they've never heard these words before. Anyway, number 8, we're doing S.8, slope-intercept form, write an equation from a graph. So we're going to look at the graph and hopefully write the equation from that graph. So didn't preview it. We'll take a look and see. So it looks to me like we have a negative slope, first of all. And let's move it up to where we can write the equation for it. And it looks like our y-intercept is at 0, -3. I'm going to go ahead and point out that. It's this graph, this line of this graph rather, is intersecting our y-axis at the point 0, -3. That means that -3 is our b value. And we can count the slope from here to here, which is down 1, 2, 3, 4 over 1. So the slope is -4/1. And that allows us to write the equation, which of course is y equals -4x plus -3, but we usually just write the -3. So there we have it. So it's going to take a little while because I've got to type it in. Let's see, there's my keyboard. Whoops, there's my keyboard. There it is. So y equals -4x, yeah. -4x minus 3. And we're looking at another graph, yada, yada, yada. Looks like our y-intercept value is -2. And it looks like we can go from this point. We can count from this point down to this point, which looks like down 6/2 or down 3/1. So the slope is -3/1 if you like. And the y-intercept b value is -2. And so we have an equation. Y equals -3x minus 2. This is a positive slope. I can see that immediately. Well, one of the things you want to pay attention to is what kind of slope you're looking at. Now, the other thing, this is not very steep, so it's going to be some proper fraction. So the y-intercept, the b value, is at -1, and the slope, if we count it from here, now we can count it from another point. It looks like it's going over to 60, up 10 over 60. Up 10 over 60, but that is 1/6, and you do have to reduce these guys. So we'll move it up here. Let's see if I have enough room yet. So y equals 1/6. I don't see a fraction bar. That's interesting. And now one of the problems with this is that this is my equation. I'm going to write my equation real quick here. So y is equal to 1/6 x, and it looks like it's -10, not -1. Got to be careful with that. The other thing I need to point out, it wasn't -1, it was -10, as you can see from the graph. Got to be pretty careful with your units there. The problem is that I don't have a fraction bar to use, so I can't really write it like this, like this. I can't write it like that. So what I'm going to do is I'm going to write y equals 1/6 x minus 10. Now the problem with that is that this literally says take 1, divide it by 6, multiply it by 10, and then subtract 10. It may work, but there's a lot of times in algebra where this type of fraction bar isn't going to, it's not going to do the division first. So a good idea is to put it in parentheses whenever you have a fraction like that. This is a good habit to get into, especially if you're using some kind of graphing calculator that doesn't have a fraction bar mode on it. So I'm going to go ahead and put it in parentheses each time. So it's extra work, but what can I do? Oh, I can't. Oh, they're not going to let me. All right, well, let's see if it works anyway. It should. All right, let's see now. We're going through 0, -8. And so, and I'm going to go ahead and mark my points so you can see them a little better. There's that one. And it's a positive slope, isn't it? And I'm going up 3 over 1. And I'm making sure I checked my the sizes of my points there. All right, so it looks like we have y equals, it definitely looks like we've got a 3 over 1x minus 8. Oh, I like this one. This is more, but one of the things about real life graphs is that they're almost always in quadrant 1, where everything's positive. There's a lot of cases in real life where negatives don't make any sense at all. In fact, we haven't figured out how to control time yet and can't seem to go backwards. So negative graphs aren't really appropriate anytime we're talking about time. We don't know exactly what these numbers represent, but they are counting by tens. Be careful on your size there. All right, so it looks like we're going through 0, 60, of course. So B is 60. Remember, the y-intercept isn't 60, it's the point 0, 60. It's also our starting point. If this was a word problem, then it might start at $60 if I were saving money, for example. And the slope looks like it's gone up 40 over 10. So the slope looks like it's 40 over 10, which does need to be reduced to 4. I could write 4 over 1, but they're probably looking for the 4. So, yeah, there we go. Y equals 4x plus 60. That's good. This one's going through 0, 1, and it looks to me like it has a slope of 5, not 6. Be careful, that's a really common error. Notice that it starts at 1 and then ends up here at the 6. So it only went up 5 over 1. So that would be y equals 5x plus 1. And this one goes through 0, -6. And it is a negative slope. Notice it's going downhill. And from here, oops, come on. There we go. Definitely looks like it's going through that point there. It looks like it's down 1, 2, 3, 4 over 1. So it's going to be a -4. The slope is -4 over 1. And the y-intercept is at 0, -6. And I'm sure you can do it yourself by now, but I'm going to go ahead and finish it myself. And of course, you can always watch it. Now, one of the things I'm noticing is that I have equal intercepts. I have the point here, and I'm going to point this out just to kind of show you something. This point is at 0, 8, which is the y-intercept. And this point is at 8, 0, which is the x-intercept. And you'll notice that the x is equal to the y in this particular case. And that means that my x, the change in x, is the same as the change in y. That's because since this point is included and this point is included, it means that we have a slope of -1. Well, you can count the slope in many different ways because this point and this point and these points are all included along here. The y-intercept is occurring at 0.8. So we've got an equation in slope-intercept form. Y equals -1, x. Oh, you don't have to put the 1 if you don't want to. I'm going to go ahead and put it in, plus 8. You could just simply put -x. Would be just as appropriate. Now this one is a positive slope. That's one of the first things you want to notice right away. I'm going to move it up before I start. There we go. Now I'm going through the y-intercept at 0, -3. And notice I keep emphasizing that. That's because so many books get it wrong that you have to unteach that mistake. So we're going through 0, -3, and it looks like we're also going through the point -2, 4, -2. So it looks like we went up 1 over 1, 2, 3, 4. So the slope looks like it's 1/4. And hopefully you can write your equation from there. Y equals, hopefully it won't give us any problems with the fraction, 1/4 x minus 3. Now, oh, my graph's way at the bottom this time. Okay, so let's move it down here. Got to watch out for the scale. The scale factor is the numbers that you're counting by, which are tens. Now, occasionally, you're going to get a situation where the scales are different, and that can really mess up your slope, especially if you count the slope using units. Let's take a look here. It looks like we're going through 0, -100. Looks like our y-intercept. So here, 0, -100. And it is a positive slope. It went up 1, or actually 10, and over 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be up 10 over 8. So the slope is 10 over 8, or just simply 80, or simply 1/8. So we'll put in our equation. Y equals 1/8. Oh, 1/8, yeah, x minus 100. Looks good. Looks like we have a y-intercept at 4, and it looks like this point is included right there. It's also this point right there, so it looks like it's a -1/3 slope. So it looks like we have y equals -1/3 x, and it's plus 4. This one is a positive slope of 1, but I'm going to go ahead and check my units just to make absolutely sure. It's actually 100 over 100, which is 1. But again, be careful with the scale because it could be different, which would mess up your slope. So let's see if I can move it down here. There we go. So it's going to be y equals x plus 800. I believe that was an 800 over there. So I'm going to move it down just to make sure. Yep. And it is 1x if you like. You could write the 1 in front of the x or not. It is assumed that that coefficient is there or not. And this one goes, looks like -3, doesn't it? It's really easy to get this backwards. -3 and -1/3 are easy to get confused. This is a really steep graph, so we can see clearly that it's going to be the -3. So it's going to be y equals -3x. And let's look at the number again, 8 plus 8. Get to talking too much. There we go. And it looks like we're going through 900, and it does have a slope of 1. We have the same units. We're going up by hundreds. So I'm going to write the equation right here where I can see it. Y is equal to 1x plus 900. And you don't have to put the 1 if you don't want to. There we go. And this one, we've got it going through 0, 7. There we go. 0, 7. So we also have a slope that looks like it's going down 6 over 1. So that is a slope of -6 and a b value of 7. So we can substitute it into our equation. Y equals -6x plus 7. Now, here's a problem. A few people may get their x-intercept confused with their y-intercept. It doesn't matter which one you choose for the way that we're writing the equation, since we're using the b value and not the intersection for the x-axis. Yeah, I guess I'll go ahead and write it. It looks like it's going through -30, and it definitely has a slope of up 30 over 30, which is +1. So write it. Don't forget y equals x minus 30. And that's all. Come on. There it is. Okay, very steep graph, and it is definitely negative. Take a look at that. It's looking like we're going through -10 there. So 0, -10 is our y-intercept, and it's going down a lot. Looks like it's going through that point there. So it looks like it went down 70 over 1. So the slope is -70 over 10. It shouldn't say 1, which is -7 over 1. So it looks like we have an equation. Go ahead and put it in. Y equals -7 x minus 10. Looks like that's it. Yeah, that's good. And this one, we've got it going through 0, 5, and it's a slope of 1, isn't it? X plus 5. Y equals x plus 5. Don't want to spend a lot of time on those types. This one has a slope of 1 as well, so this one's going to be x plus 3. Looks like we're getting there. And let's see, this one is going through, looks like a slope of 1 again, 10 over 10, which is 1, and it's going through -70, so it's y equals x minus, oops, minus 70. Looks like it's okay. And this one looks like it has a slope of, ooh, a little bigger. I'm going to go ahead and mark my points here. Looks like it's going through this point and up 1, 2, 3, 4, 5. Looks like a slope of 5 over 2, doesn't it? Let's double check it. 1, 2, 3, 4, 5 over 2. Yeah. Slope is 5 over 2. That's up 5 over 2. It is definitely positive. It's going uphill. And it looks like it goes through 0, -7. So we have our equation. Put it in. Five over 2x would be good. There we go. And it looks like we have a slope of 1, so it's x plus 7. Almost a slope of -1, but not quite. It's a little off, so be careful. It's pretty close to -1. It's a little bit, not quite as steep, but I'm going to go ahead and find some points to, that looks like an intersection, and so does that. So it looks like we went down 3, but we went over 4. So this slope is -3 over 4. Really easy to make a mistake there. It looks a bit like, looks like you could make a mistake there. And it's going through 0, 5. So we know what the y-intercept is. It's y equals -3/4 x, and it's going to be +5. And how many more we have? Looks like 3 or 4. All right, this one's got a slope of there we go. Looks like it's going through 0, 7, so b is equal to 7, of course. And it looks like it went up 1 and over 1, 2, 3, 4, 5, 6, 7. Looks like a 1/7. I could see somebody messing this up, calling that a slope of 7. Be careful. It is a slope of positive 1/7. It's going up, but not very quickly. So we've got y equals 1/7 x plus 7. And looks like we've got a couple more. This one's going through 0, -4. And it's slope of 1, so it's x minus 4. Yep, 1. And this one also has a slope of 1, assuming the units are the same, or the scale is the same, and it has the same scale. Like I said, be very careful. This is a slope of 1, and it's going through -300, so it's x minus 300. Y equals x minus 300. Yeah. And maybe 1 or 2 more. All right, we're going through -100. And again, we have a slope of 1, so nice easy one. Y equals x minus 100. Make sure of my scale. Yeah, let's see how it's going through 100, 0 as well. Looks good. And they are going to make me do a last one. Okay, we're just about there, and I'm sure you haven't been watching this since then. So it looks like we're going through 0, 9. And so our equation is going to be y is equal to, we have a +9 because it's going through the point 0, 9. And it looks like we have a -2 for our slope there. So it's going to be -2x plus 9. Okay, guys, I hope this one was easy enough for you, and I hope you'll go and practice. The importance of practice is that even though you know what to do, the practice will make it so that you don't have to keep relearning it over and over again. So good luck. Hope you can get to your 100, and I'll see you back again. Bye, everybody.